today we're going to be talking about what I would consider kind of an undiscovered gem in JMP, and it's called the Process History Explorer. As we talk about the analytic workflow of getting data into JMP and then doing things with JMP and sharing the results of that analysis or those insights, the Process History Explorer really kind of fits into this data exploration point. But of course, there are lots of other things we can do in JMP, but we are going to be focusing on that tool today. It is part of standard JMP, and it comes with all licenses of JMP, so you have access to it if you have JMP. I'm going to show a tool, and I'll just show it right up front, and then we'll kind of talk about why that tool exists. Maybe kind of wrap our heads around that. And then and what I'm going to show at first is some semiconductor data. But if your data is not semiconductor oriented, don't worry about it. Don't tune out. We're then going to go to a completely different data set as a case study, and we'll start to kind of dive deep into lots of the options in the Process History Explorer. So I'm going to start with just a workflow that I've recorded. This is pulling up some data. We could pretend that it's pulling from a database, and it's giving me this tool. And this tool is the Process History Explorer. And it is telling me that when I run my process, this thing called tool, planar tool 8, has the lowest yield. And because JMP is interactive, I can use things like a local data filter to say, well, let me drill down one more step to when we are using planar tool 8, then what's the biggest source of yield issues or the biggest problem? And that's saying that, well, now when we're running planar route number 6 with tool number 8, that's the problem. And what I find is usually within just 1 or 2 clicks, you can work your way from, I've got a bunch of data, to now I need to go to the shop floor and talk to people because I've found a problem. So I'm going to go ahead and reverse this, and don't worry, that was pretty fast. We're gonna kind of walk through this. I want to take a moment to talk about this data structure here and how we can reduce some fairly complicated data into a very easy to digest tool. The tool itself can help us find yield problems. It can help us find stagnation in our processes. It can also help us to see when there are changeover problems that are affecting yields. And really, I'm going to kind of walk you through some data here and understand this. And this would be 2 different data tables. The Process History Explorer requires 2 data tables. And these data tables really are set up pretty much exactly how you would pull them from your database. And so it's just a long flat list of different things that I think might identify my product or my batches or my production process, different things that I think I might want to look into, as well as time in and time out. Now, I've added the yield and lot wafer to this just so that this visualization can work, because I want to walk through kind of what's going on with all these 156,000 rows. So if I look at lot wafer 1, it's got 125 different rows in it, and maybe the first layer in this process. And again, if you're used to semiconductor data, this is probably just review. But if you're not, we're going to walk through it really quickly, and then we will switch to a different data set. But anyway, so this is a kind of a complicated process. So visually looking at this data, what happens is each of these wafers that goes through production has a number of layers. And then each of those layers has a number of steps that they go through. And at each of those steps, there's a tool that's being used, and that tool will have a recipe that's used at that tool. And so I can look at, maybe 4 layers of just this one tool. And let's revert the scale here. And so I can see that this starts to get really, really complicated But what I want to do is I want to find where's the problem, right? So if I look at this data itself, back to the data table, I've got um, a whole bunch of data that could be about 1.5 billion combinations from just a fairly simple data set. Not this data view, but the actual data set itself. A fairly simple data set gets me into a lot of combinations. I need a tool that I can really distill this down to a relevant portion, and that I can do it very quickly. So take a look at a visual, and maybe this will help us to kind of understand this. Now, what I could do if I'm familiar with modeling is I could come to the Analyze menu and I could use the screening platform, and I might be familiar with some of these tools. I'll choose response screening here, and I might say, and again, this would require me to make some changes to the data, which I've added just for the sake of this, but I could say, well, of these three things, does anything really affect that response of yield? And I might get an answer to say, yes, one of them does. And so these tools might tell me a few columns in my data are affecting an output. I might want to go ahead and maybe fit a model to those, but that's really not going to work with this data, nor is it going to work with what I'm trying to do. I'm just trying to find the problem. I'm not trying to understand how everything works together. So maybe I might, instead of doing this, try to do something like a partition, and I might look at this and say, well, do any of these things influence that yield? And I can hit the split button, and I could probably get to a problem eventually after splitting a whole bunch of times, but it's just not efficient. What I want instead is I want a tool that tells me, hey, buddy, when you run this production process at these settings, this is a problem. And that tool is the Process History Explorer. So let me just pull it up. And we've seen this already, but this is telling me among all the different things that we asked for, running planar tool number 8 is the issue with yields. And again, I like to use it with the local data filter. And so if I drill down again to planar tool 8, now I have something that I can go look at in production. I can start to dig in and look at the reasons why.